Hello, my name is Mario. Welcome to another video. In today's episode, I will share with you another tip for building microservices in Go, specifically using Redis as a message broker and using PubSub. So what is Redis? Redis is an in-memory data structure store used as database, cache, and, like I said, message broker. I recorded a video and I will leave the link in the description if you want to see the one when I use Redis as a caching mechanism for caching responses in HTTP APIs, in microservices as well. So the way the PubSub works in Redis is there is a publisher or any number of publishers, doesn't have to be one, there are n publishers, and there is a channel, and that channel is used for sending messages. Now, important thing to notice here is that if there are no subscribers, those messages literally go away or disappear. They are never delivered to anybody because nobody was subscribed. So if we want to use this PubSub option that Redis has available, those subscribers must be subscribed to the channel or channels that they need to listen to or they want to get information from. So when the publisher pushes the value to a channel, that value will be sent to whatever subscribers are listening to that channel. Okay, this is the biggest difference compared to the other two videos I recorded previously with RabbitMQ and Kafka, where those data stores literally save the values for for some time, and they can be accessed after not immediately, and they can literally be received by the subscribers after a while. They don't have to be connected all the time to listening to those messages. Okay, this is the biggest difference between what Kafka, RabbitMQ, and now Redis offers, for example. So let's look at the code, and then we can see how this thing works in real life. As usual, the link of this code will be in the description, so feel free to clone it, play with it, check it out, and whatnot. The biggest difference that I added compared to the previous implementation was adding a new repository, and if you haven't seen that video, I will also be leaving the link in the description as well. There is a new repository called Task for Redis, and happens to be using Redis as the data store behind the scenes, and that data store is the one actually publishing the events from the service that also happens to be implemented or rather receiving that via dependency injection, which is similar to what we did with Kafka and RabbitMQ. And similarly to what we did in the previous episode, what is going to happen here is that it's going to be encoding the message that we're trying to send to our subscribers using JSON. So the message in the end is going to be sort of like a string-based message, nothing in binary to say it in a different way. The consumer of this, or rather the subscriber of those messages, is going to be in charge of receiving those messages and indexing and updating the values that are stored in Elasticsearch. Similar situation that we did in Kafka and with RabbitMQ. The biggest difference is obviously we are using Redis in this case. So if we go and create a new task, for example, let's call it PubSub priority high, and we execute it, we will create a new task. And what is going to happen here is that we just receive a new message that indicates the task was created. And again, similarly, if we go and search using PubSub, let me remove all of this. What is going to happen is that it's going to be returning the ID that was just created. Now I want to show you something really important, that because I'm using Elasticsearch, Elasticsearch, but I'm using Redis. I have running this publisher Redis, the CLI for the Redis CLI. Actually, I'm using a Docker container in this case, but I'm subscribed to the channel, or rather subscribed to a pattern of channels that are being used for sending the data and tasks and receiving those events back on the subscriber side. So if you can see right here, I'm literally seeing the event that was just sent from the REST API to Kafka to Redis, and then this one is actually printing out the value. Another way to see it is if I go and modify this, you will notice the value will be showing up on the left side. If I take the ID and then I go, let's say I delete it, I will be receiving a message as well that says, hey, the value was deleted. And this is sort of compared to the previous episodes with Kafka and RabbitMQ. The biggest difference is that I'm not using one single topic or channel or queue. In this case, I'm literally using different channels for each one of the message types that maybe probably could make sense in your use case. And I want to show you how this is implemented. So I have a channel right here, and I'm pushing this channel, publishing using this API called publish. On the subscriber side, the way it works with Redis is that you can use a wildcard or a pattern, and then you can subscribe to whatever pattern you want to subscribe. If you notice in this line, I'm subscribing to everything under tasks.wildcard or asterisk. So everything that happens to be using prefix with tasks dot whatever is going to be listening to those messages. And if I go ahead and I say, you know what, let me create another one just for the sake so you can see another message right here. If I go here and I create a new pops up, you will notice that I'm also receiving the event, and at the same time I just received the event right here. And similarly, if I go and update the same task that I just created, if I try it out and if I change to change, I will be receiving the message also in this subscriber as well as on the CLI that I have right here. So everything is sort of, like I said, because all of those are subscribed to the same channel, all of them are receiving the events that were published by the publisher or publishers in this case. So let's jump into the conclusions and let's see what are the benefits, the pros and the cons when using Redis as a PubSub. So this is Redis using PubSub. As you can see, it's a really simple way to define messages, or rather to implement messaging between different services or systems using Redis, using PubSub. It's such a extreme and not extreme, such a simple mechanism and such a simple service that probably makes sense for your use case. Now, the cons of this is that a message, if nobody is listening for that message or there are no subscribers, the message will be lost. Or obviously, because nobody is subscribed to that message, nobody will be receiving that value. And that value will not be saved anywhere. You cannot replay it, you cannot read it or receive it after it was sent to the channel. It is extremely easy to implement. As you can see, you just need a few different lines of code. It uses sort of like a string based. The package that I'm using is using strings, but you could literally use bytes if you wanted. So encoding something using maybe GOB or protocol buffers, and that could work. This will be useful in cases where you don't really need to save the data. You just literally need to fire and forget, and probably a few examples of a few use cases will be some sort of like maybe a chat service where you don't care. In the context of the user that is joining the chat room, you don't care about the history of what happened before that, okay? Compared to Kafka and RabbitMQ, this is, like I said, super simple, and it could be useful in cases that you don't need something as big or as heavy that compared to Kafka or RabbitMQ. It's a different use case as well. So, as usual, thank you for watching, and like I said, the link will be in the description, the link to the repository, to the code, specifically the commit that I'm using for this video will be in the link, so you can clone it, check it out, and see how it works. Thank you for watching, and as usual, any comments or any questions, just let me know, and I will talk to you next time, okay? Take care. See you.